We use logarithmic differentiation if we are differentiating exponential functions. In other words, if our variable is a power. A good example is if we are differentiating y. If we're differentiating y is equals to, let's say, x to the power of x, we have to rely on logarithmic differentiation, or we have something like y is equals to, let's say, 2 to the power of time x. We can use logarithmic differentiation in this case, or something like y is equals to, in general, when we have something like y equals to f of x to the power of g of x. If we have something like this, we have to use logarithmic differentiation. That is your hint that in this case you have to use logarithmic differentiation. I'm going to start with a very simple scenario. Let us say we have y equals to e to the power of x. We know this from our formula sheet, obviously, that if we differentiate e to the power x, we get e to the power x. But this is an example of an exponential function, and we can show that the answer is actually e to the power x using logarithmic differentiation. So when you're using logarithmic differentiation, you rely on the fact that log of a to the power of m is equals to m log a. We know this from our laws of logarithms. This is what we're going to rely on, this rule of logarithms, this law of logarithms. We are going to rely on this one. However, in calculus, the logarithm that we use is the natural logarithm, or the logarithm to base e. In the same manner, we can say ln, which is the logarithm to base e of a to the power of m, is equals to m ln a. This is what we're going to rely on in calculus. All right, let me clear my board, and then I show you how to go about doing this. Okay, clear this. All right, now we take logarithms both sides. So the first step is to take logarithms both sides. So take logs both sides. Take logs both sides. I just want to prove that if we have y is equal to e to the power of x, dy dx is e to the power of x. So I'm going to take logs both sides, but as I said, we are going to use the natural logarithms. So we have ln y equals to ln e to the power of x. From here, we can say this means ln y is equal to x ln e. Guys, we know that ln e is 1 because this is like log to base e of e. The answer is 1. So ln e is 1. So in effect, I have ln y equals to x. I'm going to use implicit differentiation to differentiate this. Ln y equals to x. So I'm going to differentiate ln y in terms of x. The answer is 1 over y dy dx equals to 1, because if you differentiate x, you get 1. If you have forgotten how to do implicit differentiation, please go to one of the videos on the channel of where I explain how to do implicit differentiation. So once you have done this, you have to make now y dy dx subject of the formula. Let us go. I'm going to clear the board. Remember, we started with y equals to e to the power of x. Now we are having 1 over y dy dx is equals to 1. I want to make this dy dx subject of the formula. So I multiply by y both sides. I will have dy dx is equals to y. But we know who is our y. We know it from here. This is our y, so we're going to replace our y there. It means dy dx is equals to e to the power of x. I have just shown you what you know, but it is a very good example of showing how you apply this logarithmic differentiation, how you use logarithmic differentiation. I'm going to do another example once again. Clear the board. Now I have a function like y equals to x squared plus 4x, all this to the power of x. Y equals to, in brackets, x squared plus 4x to the power of x. This is an exponential function because the question here is find, we were required to find a dy dx. When we say dy dx, we mean that we are differentiating the function called y with respect to x, which means our x here is the variable, and the variable happens to be a power. So this is an exponential function. We have to rely on logarithmic differentiation. You may try other techniques of differentiation, you will not get it right. You have to use here logarithmic differentiation, and the logarithm that you use is the natural logarithm or the logarithm to base e, not any other. Don't use base 10. So we're going to take logs both sides, which means your ln y is equals to ln, put your brackets, x squared plus 4x, close the bracket, to the power of x. You usually get a mark for doing this, for just taking logarithms both sides. Remember guys that this is an equation, so you have to take logarithms both sides. Don't just take logarithms from one side, take both sides. All right, now we move on. Okay, let me wrap this part here. I said you get a mark for just doing this because a student who does not do this step obviously is confused. Now I'm going to simplify it a bit before I move to the next stage. We have here ln y equals to x ln x squared plus 4x. Now what we have here is now a product. If you know the product rule, we have this function here x multiplying this function here ln of x squared plus 4x. And guys, we know how to differentiate each of these functions, and if we apply the product rule, we can easily get our answers dy dx. But we are going to apply the product rule and also implicit differentiation because we don't have y being equal to something here. We have ln y, so we have to differentiate this ln y with respect to x. So I'm going to the next stage here. Use my great pen. So if we differentiate ln y, we get 1 over y dy dx equals 2. On the right hand side, I'm going to apply logarithmic differentiation. So to start with, I'm going to differentiate ln x squared plus 1. So I'm keeping my x here times the derivative of this, which is 1 over x squared plus 4x times the derivative of x squared plus 4x, which is 2x plus 4. If you have forgotten what I'm doing here, just remember that I'm applying the chain rule because this is a function of a function. I made a video on the rules of differentiation, so go there and check how to use the chain rule because this is the rule that I'm using. Plus, so I'm using three rules all at once, 3 techniques here: the product rule, the chain rule, and also some form of implicit differentiation. So I have to add. Now the next time, this time I'm going to differentiate x and I keep the other one. If you differentiate x, we get a 1. So 1 here times the lane of x squared plus 4x. Done. I have done all my differentiation. All I'm going to do from here is just rearranging the whole sum. Let me clear the top part of the board so that I can use the space. I'm going to clear this space. I want to use it now. All right. So let's use this space. So I still have 1 over y dy dx being equals to, let us simplify this part here. This x is going to multiply to x plus 4. We'll get 2x squared plus 4x all over x squared plus 4x all over x squared plus 4x, and plus the second term here just becomes ln x squared plus 4x. So ln x squared plus 4x. We are almost done. Now we have to make dy dx subject to the formula, which means we have to multiply by dy dx both sides. Okay, let me clear this part now. We don't need it anymore. All right. Now we have to multiply. I don't know, we may simplify this part here because it can be simplified. We can factor out x in the numerator and cancel out. We can do that, but not really important. So dy dx is equals to y. I'm going to put a bracket here. Then we have 2x squared plus 4x over x squared plus 4x plus the lane of plus natural logarithm of x squared plus 4x. I close my bracket. But guys, we know who is our y. We know who is our y. Our y is the original question that we were given, which is x cubed plus 4x, x squared plus 4x to the power of x. That is our y. X squared plus 4x to the power x squared plus 4x to the power of x. That was our y. So we're just going to substitute into what we have here. All right, so let me carry on. So I have here equals to x squared plus 4x to the power of x times, I put this bracket here, which is 2x squared plus 4x over x squared plus 4x plus ln of x squared plus 4x. I close my square bracket. This is the answer. This is how you do such kind of questions. In the end, don't leave your answer with a y here. Make sure you replace the y, which is usually the original, obviously, the original question that we're given is y equals to something. You take that part and replace this y here. If there is any way where you can simplify, make sure you do the simplification. Otherwise, everything will just be going like this. Let me do another example. In this case, we have y equals to sine x to the power of cosine of x. Okay, the question is find dy dx. This is an exponential function once again. The power there is a function of x. So we have to rely on logarithmic differentiation to take down this cos x. So if we take logs both sides, we have ln of y being equals to the ln of sine x to the power of cos x. Let me wrap this part here. Okay, to the power of cos x. Applying the laws of logarithms, we know that this is ln y equals to cos x ln sine x. See, now what we have is a product. What we have on the right hand side is actually a product, because we have two functions here, the cosine of x and ln sine x. So we're going to apply a combination of implicit differentiation and also the product rule. But in this case, this part here, we are going to apply the chain rule once again. So we have almost three techniques that we are applying here: implicit differentiation, the product rule, and the chain rule. We are applying them all together because this part here is a function of a function. So let's go straight to the differentiating part. Differentiation. So the left hand side will be 1 over y dy dx being equals to, guys, we always write dy dx if we differentiate a function of y with respect to x. So ln y is a function of y, and we are differentiating it with respect to x. This is how we do it. So we take it 1 over y, we multiply by dy dx. Let us go to the right hand side and apply the product rule. So I am going to differentiate cos x first. I keep this side the way it is. If you differentiate cosine of x, we get minus sine x. So minus sine x times ln sine x plus, now I'm going to differentiate this other part here. Now I will differentiate this part. So I have cos x times 1 over sine x, 1 over sine of x. I multiply that by the derivative of sine x, which is clearly an application of the chain rule. If I differentiate sine x, I get cos x. So this is cos x. All right. Yes, I'm there. Now let us finish the question. Now this part here, we have done all the differentiation that we have to do. Whatever we're going to do going forward, we are just trying to make dy dx subject of the formula, which is the last part of this question. It is to make dy dx subject of the formula. All right. So let's go to that. Let's make dy dx subject of the formula. So from there, it means dy dx is equals to y. Let me use a different color to illustrate this part. The first term, this term here, is quite straightforward. It is minus sine x ln of sine x, then plus this second term here. It can be written in different forms. You can write this as tan x, no, cot x, cos x, because cos over sine is cot x, or you can write it as cos squared x over sine of x. So I want to write it in that form. This is cos squared x over sine x. I close the bracket. Everything that I have written here is legal. It is correct mathematics. It is all right. But we know our y. We know our y, which was our original question, by the way. It is sine x to the power of cos x. So we have to replace the y by sine x to the power of cos x. which is the last part of this question, which is equals to sine x to the power of cosine of x in bracket minus sine x ln of sine x plus cos squared x over sine x, close the bracket. That's it. Let me give you a final example or another example here. Another example is, let us say we have y is equals to x to the power of x squared. Okay, let me rewrite it. So y is equals to x to the power of x squared. Once again, this is an exponential function because our power is actually a function of x. Let us go straight to how we work out this question. I'm going to take logarithms both sides. So it's ln y is equals to x squared ln of x. I'm simply applying this rule quite fast. I think by now you can see the drill, how we do this. To the left hand side, we're going to have 1 over y dy dx, and to the right hand side, we're going to apply obviously the product rule. Let us start by differentiating this. So we have 2x ln x plus x squared times 1 over x. If we differentiate ln x, we get 1 over x. We have this on our formula sheet. Then we make dy dx subject of the formula. So dy dx is equals to y 2x ln x plus, if we simplify this part here, we get x. That's it. But we know our y. So the final step is simply to replace your y with this, because it is the original thing that you had. Let me clear this top part of my board and just write the, okay. All right, so the final answer is just dy x is equals to, where there is y, we're going to put x to the power of x squared, open the bracket, we got 2x ln x plus x. This is our final answer. That's our final answer. And we can get all our marks. Thank you for watching the video. If you have any comments or any questions, just write on in the comment section below. I'll respond to you. Otherwise, subscribe to the channel and give a thumbs up to the video. Thank you.